We are in Revit now, our old friend Revit. I remember that last time we opened Revit here in Analyze, you should have now the lighting and the solar analysis. Do you have these tabs on those computers? You do, okay. We are not going to use it today, but we need this for, especially for PV panels and all that stuff. So let's go to architecture. We're going to do something very simple. Let's create a wall, any wall, generic wall, and we are going to create like a 10-foot by 10-foot square. Okay, so we have a masterpiece here, and let's look at the elevations. So on the elevations, I recommend you get rid of all these levels that we don't need. So we just need level 1 and level 2. We don't need roof or nothing else, okay? So we have level 1, level 2. We have a box that goes from level 1 to level 2. And on level 1, I'm going to place a floor. So let's go to architecture, floor, and with a rectangle, we just have a floor here. And we're going to place a roof. So architecture, roof on level 2. And I'm going to create another rectangle. And do not define slope because I want a flat roof. And there you go. Okay, so this is the simple space or building that we can have using Revit. We have a square, 10 by 10 by 10, and a roof, a floor, and walls. We can add a window. So let's add a window, and let's add the fixed window, this one, 36 by 72. Here. Yep. So that's it. Is this all we need to start the thermal simulation in Revit? No, we need something else, and it's not intuitive. So that's why I have to explain it, because it's difficult to understand. So you have to get used to doing it many times. We have to, when we want to analyze this from the thermal point of view, we need to work with spaces. You know that we have rooms. So if we are on level 1, we can use rooms. And if we click here, don't do it. But if we have rooms, we have the area and we have different properties of the room. But rooms don't work to simulate the thermal properties of the building. So we have to use spaces. So we have to go to analyze, space, and no. So you see that when we click space, we have this red rectangle, and when we are here, the rectangle adapts the shape of the room. Okay, so that means that it's a good thing. And then we do this. And we don't see the space. If we hover the mouse, we find the space here, but by default, it's not shown. So when we are working with thermal simulation, I always recommend use visibility graphics and go to spaces here. So click on this sign and activate interior and reference. Then apply, and then the space shows up. Okay. It's in visibility graphics. In filter list, you have to make sure that mechanical is activated. If you don't activate mechanical, spaces don't show up here. Okay, so you have to activate mechanical, and then spaces are here. Yep. And then you have to click, and click on all the things, color field, interior, and reference. Okay. Now, if we have one room with one space, it's easy to understand. But if we have, imagine this building, how many spaces we can have in this building? 100 or 200? I don't know. Each office, it's one space. This room, it's one space. The other room is another space. So we can have, in complicated buildings, we can have hundreds of spaces. So again, naming spaces, it's something very important. So how can we name a space? If you select here in this properties windows, you see that here we have space. So we have selected that. And at some point here in identity, we have the name. So we have the name is space and the number is 1. Okay, it's a name. If you can remember, if you have 200 spaces and you can remember what space is the number 154, great. I don't have this, so I prefer to name those spaces. And then we need a code. We cannot name a computer lab or whatever, because when we are designing a building, we don't know what the computer lab is going to be. Or so I recommend you, if you want to name that space, so it's first floor, space number 1. Or, but I don't know, I'm very bad at naming things. So if you find a better criteria to name things, go ahead. Okay. Again, if we have a single family house with 3 bedrooms, a living room, and a kitchen, probably it's not that complicated. But if we have a high-rise building with 30 floors and 50 rooms per floor, it's because the information that we get is the information from the space. Okay, so we are analyzing the building, but we are analyzing different spaces. And the report that we get from REVIT is space 150. So what is the space 150? At least if you, okay, it's in the 5th floor and it's the space number 7. Okay, so let's go to the 5th floor and let's try to find out what space this is. Anyway, we need a space name or a number or whatever. Then here, this is what we need. We need to understand the energy analysis parameters here. The first thing that we have to check is plenum or occupable. What is plenum? I explained what plenum is in another video, and on Wednesday I will explain it again here. But the plenum is, for example, the space that we have between the false ceiling and the slab. It's a space because we have air, but it's not occupable. So there are no people living there. But it's air, it's indoor air, and this space is limiting with the space that we have above us. Okay, so that would be a plenum. Plenum is the space between the false ceiling and the slab, if we do have a false ceiling. If we don't have a false ceiling, here we don't have a false ceiling, it can be occupable. Okay, so because that means that people can live in that space. Condition type, by default, we have heated and cooled. We can have a space that it's heated, but it's not cooled, or we can have a space that it's unconditioned. If we have a mechanical room, we will click here, unconditioned. And that affects, because if that room is beside a space that doesn't have heating or cooling, we are losing some heat through that wall. Okay. So by default, most of the spaces will be occupable and heated and cooled. So by default, we can have this. Then space type, that's even more important. So if we go to space type for a building, here we can define all these parameters. So let's go over the area per person. That's the occupancy in terms of area per person. For example, if this room is, let's say, 20 by 20 feet, if we have 400 square feet here, and there are 20 people, what's the area per person? It's 20 square feet per person. Okay, so 20 square feet per person times 20 people, it's 400. Okay, so in this case, if we are analyzing this room, the area per person, it's not 370, it's 20. Sensible heat gain per person and latent heat gain per person. So that depends on the activity that we are doing here. If this is a gym and we are sweating and moving, and whatever, we will generate more heat. If this is an office or it's a classroom, so we can leave this by default. Anyway, we can change that, and that depends on the activity. So when it comes to the energy analysis, we have the occupancy. So how many people we have in that space, and then the sensible heat, and that depends on the activity that we have in this room that we are performing in that room. Then the lighting low density and the power low density. So that means the number of lamps and the number of computers or devices that we have in this. Okay, so we can keep this by default, but this is something that will affect that. The infiltration airflow per area. Infiltration, so infiltration matters. Okay, so those are CFM per square feet. We have to talk about this because that matters a lot. Okay, so infiltration, again, it's something that we don't want infiltration. Infiltration is the air that enters the building, but it's not part of the mechanical ventilation system. It enters the building through cracks. So that means that the building is not well done. But again, it's impossible. We can't create a 100% perfect building. So we have to assume that there's some infiltration. But it's something that we have to reduce. Up to zero. Zero is impossible. So let's keep this, but we will talk about infiltration. Then plenum light contribution. I don't know what this is. So let's keep it this way. This is new to me. And then occupancy schedule. Occupancy schedule, that's important. Here we have, remember that in systems, if we work with the occupancy, we have the schedule from midnight to 6 a.m. The building is empty. Then from 6 to 7, we have this kind of. Okay, so here we have the common office occupancy, and here we have the schedule by default. Okay, so that means that at 6 a.m. The building starts operating, and we have full occupancy from 10 to 12 to 11. Then there's a lunch break or whatever, and then we have another full occupancy here, and then it's okay. So, but you see that we have a hotel. Hotel is different because we usually are in our rooms during the night, usually. So if we have a healthcare facility, it's like this. If we have a commercial, whatever, so that's it. A restaurant. This is the warehouse. And do we have residential? Yes, so residential, that makes sense. We wake up at 5 a.m. Yeah, why not? And then we are there, we have breakfast, then we leave, or some people leave, some people stay, whatever. And then we are all there like a happy family for dinner. Perfect. So that's the schedule settings for a residential building. And then we have a school, makes sense. And then, okay, so let's, I think by default was the common office occupancy. Okay, so let's leave this one, but that matters. And we understood in systems why the occupancy matters. Okay, so make sure that you select and we can have on 24 hours. or off 24 hours, doesn't make sense. Or we can have from 6 to 10. So there are different options, but I recommend you this one because we have peaks, okay? So, and we have to adapt our system to the peaks of occupancy. So let's select common office and let's click OK. Then lighting schedule. Again, here we have different options. So the lights are on all day long, and then we turn off the lights. Okay. The power schedule, the same. Usually in an office building, everything is on at the same time and everything is off. And then outdoor air per person. This is 5 CFM. So that's the, we have outdoor air per person and per area. And the outdoor air method, here we have per people and per area. So that we can have two different conditions. And here, with this option, it selects the most demanding condition. Okay, so if the air that we need per people is higher than the air that we need per area, then it uses always the highest value. Air changes per hour, well, there are like 3 different parameters. So we can select by air changes per hour. I would use one of those. Well, usually, you remember what was the air per person that we used in systems? $20 CFM per person. Okay. And then can we have, if we go to the ARCH360, probably there are 2 requirements, 20 CFM per person or 15 CFM per person and 20 per square feet. Okay, so we have to go to that, but usually if we use 20 per person, that will be, and if we want to make sure, here select maximum by people. Yes, this is what I would select, maximum by people and per area. Okay, so here we can have 20. 20 is the, well, it's, I told you that this is always the minimum ventilation airflow. If we have more than 20, that's fine. But usually the requirements are from 15 to 20. If you have a restaurant or a smoking room, it can be more. But in most of the, 20 works for most of the spaces that we can get. Then the heating set point. This is the comfort temperature, 70. That makes sense. Okay, so that means that if the temperature drops, it's below 70, the heating system starts. And the cooling set point, that means that if the temperature drops, no, the temperature is above 75, then the cooling system starts. That makes sense. Okay, but when we generate a space, we have to make sure that all this we have all these parameters. I mean, we control what we are doing, okay? Because we can make a huge mistake if we change, if we don't have the right schedule or if we don't have the right airflow per person. So we can make a huge mistake with that, okay? So once we are done with this, we click OK. And what else do we have here? So we have the space type in construction. Well, when we don't define the details, here you see that I have selected this basic wall. Okay. If we have layers with the thermal conductivities, we don't have to do anything with that. But if we don't define the materials in construction, we can use the roofs. And here we have a lot of options. In construction, okay, so if we activate construction, here we have a lot of options for roofs. It's overwhelming, the amount of options that we have. Okay. So let's select for roofs and exterior walls. and the exterior windows, it's a double glazed windows. Okay, so let's select these by default. And then for floors, passive floor and insulation. So let's select this option for roofs, walls, floors, and exterior windows. But if we define this in the with layers, we don't have to click here, okay? And then we select the building option. But if we haven't selected anything, let's select this. And something else. People. We can change the number of people, or we can select by space type. If we have defined 20 people per square feet, we can do that. But here we can change, and here we can change the heat gain per person. We can specify, those are the values that we have by default, but that's it. Okay, so here I specified 20 square feet per person. So that means that that square feet we have 4 people. Okay. Okay. And we can have the electrical loads. Again, we have specified that in the space type. And sport. And that's it. I'm going to calculate my first report of the year. So we have this, we have calculated or we have defined the space with all the parameters. So here, if you click, well, first we have to click here, create energy model. So create energy model, and you're about to create, okay. And this is it. Okay, so we have this view, which is the analytical models. If everything goes well, we will see something well defined. If spaces are complicated, there will be weird things in this view. But here, well, everything is correct because is everything correct? Okay. And before doing anything here, go to space and zones. Okay, so here in Analyze, space and zones, and in area and volume computations, select areas and volumes. Okay, and now we have the energy analysis, the energy model. So now we can generate the systems analysis, do this, and we are going to select the first one, annual building energy simulation. Then run analysis. And let's see what happens. It's calculating the background. So the model is so simple that it won't take that long. Here on this project browser, you see that at the bottom we have reports and analysis reports, and we are doing this analysis report. So it's still calculating. So when it's done, it will. So it's calculating. You can keep working. Okay, so it's creating calculations, but you can keep working on the file. We are not working, but because we want to see. Okay. And here we have a nice report. Most of this information is useless, okay? But here in report style, I want to see loads. Okay, so here in loads, this is the first analysis, and I think it's quite good. We have the cooling and the heating. Okay, so we have the cooling loads and the heating loads. Here we have the maximum cooling and heating loads. Okay, so we will use this to dimension the system. And here we have information of this is heating of what we lose through the roof, through the glass, through the wall because of the infiltration and because of ventilation. Okay, so here we have everything that we need. So it has taken into account the R value of the walls, the R value of the roof, the windows, the solar gain. Okay, so we have a lot of information here on this analysis report. And this is the total in BTU hour. So that total will be 4,600 BTU hours. And it's split into sensible and latent, but okay. The figure that I would like to see here is the total. And then if we want to change something, here the walls out of 4,000, we have 1,800, almost 1,900 through the walls, and 1,500 because of the infiltration. Okay, so if I had to do something here, I have to fix infiltration because it's a lot. Okay, so I'm losing 200 through the roof and 1,500 because of the infiltration. So the problem is that infiltration, it's something that I declare that, okay, I want like this percentage of infiltration. So the percentage of infiltration that I have placed when I was adding all the properties of the space, it's too much. Okay, so this is what, and then the walls. Okay, so infiltration, I think it's the biggest problem. And then I will try to place more thermal insulation on the walls. And then probably I will change the glass double glazing by triple glazing. But here in that space, the window is so small that the glass is not an issue. Okay, so if we had a lot of glass, probably the glass would be the problem number one. So that's for heating. And for cooling, we have the most significant amount is the glass solar. So these are the heat gains that we are receiving through the glass. So we have to address this. So probably with a shading device, we will solve this issue. And another thing that catches the eye, cooling, we have 10,000. In heating, we have 4,000. Okay, so cooling, it's more important than heating. In this space, where is it? Okay, good question, because we didn't do that. In location, usually it's in Boston. Yeah, by default, it's in Boston. But it's surprising that in Boston, with this building, cooling is more demanding than heating. Okay, so